Hey guys, so we're going to go over the membranous stage of vertebral column development. That's on page 12 of your book, and I have gotten a few requests to talk about it, so hopefully this is helpful. So we'll start off by just checking out this very awesome drawing that I made, so cool. You are welcome to take a screenshot of it if you like to write things out yourself, and I'm just going to kind of color things in and go a little bit step by step to try to explain things. So first of all, I want to point out this is the notochord. There's a lot of confusion with the notochord. Typically, it will be asked as a test question, so do know what the notochord is, but more specifically what the notochord is not. So the notochord is not equal to the spinal cord. This is just part of embryologic development. It kind of forms a bit of the scaffolding, if you will, of the vertebrae to start to develop around. So it all starts with this, with our notochord. So that's going to be in blue everywhere. It's in blue down here as well on that view from above. So views 1 through 5 are looking at the developing spine, so it would be like looking straight on or straight from behind, whereas this one's looking kind of either from the feet or from the head, that kind of direction. So you'll notice that the notochord is here. It is not here. This would be the spinal cord. So that's important to differentiate. All right, so we have our notochord. Then we have, so step 1, somites are going to be in this beigey color. Somites are made from paraxial mesoderm. They are going to start to surround the notochord. The somites, then differentiate into sclerotome, myotome, and dermatome. So the important part here is our sclerotome, because that is going to be what gives rise to the vertebral column. So I would know that the sclerotome gives rise to the vertebral column, and those are going to be in pink. Myotome and dermatome, very important, but not for this purpose, so I'm going to leave them uncolored, and we'll get rid of them shortly here. So then we move on to step 3. In step 3, that sclerotome, which was in that pink color, remember, which was a derivative of the somite, it migrates to surround the notochord. The notochord's in blue, and that becomes a new structure called the perichordal blastema. So the perichordal blastema is in that purple color. Moving on, I had to make the writing a little bit smaller. Hopefully you can still see it okay. So we still have steps 1, 2, 3. We already got to there. We've got this purple perichordal blastema. So next, what happens is that perichordal blastema continues to differentiate. It differentiates by a lot of cellular changes that happen very quickly. So the 2 different types of cells start to form. We've got these ones that are wind up being called loose cranial sclerotomites, and we've got dense caudal sclerotomites. So this, I think, is pretty easy to remember. It's the next steps that can be a little confusing. So make sure you understand this. Dense is at the bottom, loose is at the top. And those two are so different. Their cellular structure is so different that there's a line that separates the two of them. There's a distinct line. And that's going to be called the intrasclerotomal fissure of von Ebner. It's a mouthful, I know. You're going to want to know that for sure. So know that the intrasclerotomal fissure of von Ebner it separates the dense caudal and the loose cranial sclerotomites. Okay, another important factoid is that the intrasclerotomal fissure of von Ebner is the first indication of the intervertebral disc location. So that is typically a fill-in-the-blank question. So it will be simple. What is the first indication of the intervertebral disc location? And that's going to be this entire word salad. So the intrasclerotomal fissure of von Ebner. Spelling counts, so know that now. All right, now we've got all of our steps. We've gotten here to the differentiation of the loose cranial and the dense caudal, and then there's a migration that occurs. So remember, dense is going to be heavy, it wants to sink. Loose is going to be light, it wants to rise, like a gas. Think of it that way. So our dense caudal sclerotomite migrates downward, and our loose cranial sclerotomite migrates upward. So these two, the middle two, that dark purple and that light blue, migrate and come together and become a more uniform cellular structure. They form the vertebral blastema. So there will be lots of questions, there's often questions about this. So note that the vertebral blastema is formed by the dense caudal sclerotomite from the segment above combining with the loose cranial sclerotomite from the segment below. So know where the dense and the loose are coming from to form a vertebral blastema. And then, so remember how we talked about that intrasclerotomal fissure of von Ebner and how important that was, and it separated those two very distinct layers of cells, the loose and dense sclerotomites. So after that migration happens, there's on either side of that intrasclerotomal fissure of von Ebner, there's a distinct layer of cells, and that becomes the perichordal disc, so that's going to be in green. So if you can imagine how that migration occurred, suddenly those become this green, which is the Sorry, I messed up a little bit there. But anyways, the green is the perichordal disc. All right, so that is it. So know the important things. Know that the nodal cord is not the spinal cord. Know that the somites come from paraxial mesoderm. Know that those are going to be what surrounds the nodal cords. They differentiate into three different things: sclerotome, myotome, and dermatome. The thing that turns into the vertebral column is going to be the sclerotome, which migrates to surround the nodal cord and becomes the perichordal blastema. So definitely know perichordal blastema. Then the perichordal blastema differentiates into loose cranial and dense caudal sclerotomites. And then when that migration occurs, remember the loose goes up and the dense goes down, we're going to have this vertebral blastema. So this is kind of the end game here. That vertebral blastema is going to be separated by the perichordal disc. The perichordal disc is going to become the future annulus fibrosus. So that's another typical fill-in-the-blank question. What becomes the future annulus fibrosus? That's going to be your perichordal disc. If he's asking what is the future site of the first indication, of the intervertebral disc, that's going to be your intrasclerotomal fissure of von Ebner. All right, I hope this was helpful. I'm sorry this is my first one, and I will hopefully make some more of these if you enjoy them.